Okay, so what we were doing at the end, so this is just more examples. We're continuing on. Let's write the question down first. All right, so let's see if you remember. So we want to simplify this. And we're talking about factoring in here, so at some point we have to factor. Do we do anything first, or do we jump right to the common denominator? Right, we want to factor the denominators, the bottoms, first, before we start. What would be the reason for that? To find the common denominator, what we don't want to do is just take these blindly and multiply them by each other, because then we have to do synthetic or polynomial long division. It makes it much, much worse. Remember, with numbers, and we did this last class, if you had, let's say 1 over 36 minus 1 over 18, is the common denominator 36 times 18? Hopefully not. Right? If we factor these, what is the factors, or some factors of 36? 6 times 6, and what about 18? 6 times 3? Okay, so one common factor, we could say, okay, well, they both got a 6 in it. This isn't the best one for this particular example. Do you see it? So do we multiply this one by 6 and this by 3? No. Do they break down further? It's good to say yes. Do they break down further? Yeah, actually they do. What's the 6? We could say this is 3 and 2. Do you agree? So actually they've both got an 18 already in them. You might have noticed that right off the start, but I wanted to show you that factoring, get it down as low as you can and then compare them. So they both already have an 18. So to find the common denominator, what do we actually need to do here? Just the 2 to the second one. That keeps the numbers nice and low. We want to do the same when we've got letters in it. We want to factor and keep them as low as we can. Because if they're high, you end up having to do polynomial long division, which we're not going to do. So there's our first. And what's this one? That was a common factor. Pulled out an x. What's this one? Difference of squares. X plus 2, x minus 2. All right, so what do they both have? X plus 2. So they both have an x plus 2, so we're not going to put that back in. It's in both already. What does the first one need that it's missing? Oh, stop. Stop. Let's not get ahead. What do I need to do first? Yeah, we can actually cancel something. This one we can't. There's an 8. But look at this. It has an x squared and an x. What's x squared over x? One of the x's cancel because that's x times x. So x. So we can actually write that's x times x. So one of them will cancel. Yes, thank you. We have to remember whenever we cancel something with an x in it. What factor did we get rid of on the bottom? Just an x, so what would make x 0? It's just 0, right? X can't be 0 here because it would make a 0 on the bottom. All right, so we'll remember that for later. Okay, now common denominator. What do we need to do? The first one by x minus 2. On top and bottom. The second one, nothing. It's already okay. It already has the 2 factors. Now when you get the common denominator, write it as 1. Keep your brackets in the top. Watch out for that minus sign in between. All right, do we cancel that x minus 2 now? No. Never. Right, collect the like terms, multiply this out. Okay, now what? Factor the top. What if it doesn't factor? Then you just stop, right? But if it does factor, either they have a common factor, you can cancel something else out, or you just factored in, it doesn't cancel. All right, so 8. 2 and 4? We want it to give a -2. -4 plus 2, good. So what cancels? This. And if you messed up the signs there, can you see that you might cancel the wrong factor? Yeah, so you do be careful of that. Now, we canceled out an x plus 2, so what makes that 0? -2. So here, right now, we can't have 0 or -2. And I would have lost a mark on this one myself because I would have forgotten that 0 up at the top if someone in the class hadn't said x can't be 0 way up here. Right? So you do have to be careful of that. Every time you cancel, say to yourself, oh, did I cancel an x? If you didn't, then it's not a condition. But if you did cancel an x, you have to watch for that. Now, I say I might have missed it, but it was actually on my sheet here, so don't miss the 0. So I may have not missed it, but I could see myself doing that, because I am prone to silly mistakes. All right, let's have another one. I want you to try to factor this before I do it. Now, I put a multiplier times, so we don't need a common denominator. So don't get ahead of yourself just thinking, I see 2 fractions, I need a common denominator. Right? Common denominator is only used when we're adding or subtracting fractions, not when we're multiplying or dividing. Okay, so 1, 2, 3, 4, 30 seconds for factoring each of these. 2 minutes on the clock, see if you can factor everything there. Now I'm going to interrupt and remind you, if you multiply fractions, we don't need a common denominator. How do we actually multiply fractions? Multiply the top, multiply the bottom, which when you're doing a question like this is really just like this. Okay, so I wrote one big fraction, the 2 on top and the 2 on bottom multiplied. You're not going to actually FOIL them out because you're looking for something to cancel. So you're just going to, when you rewrite it with all your factored forms, you're going to write it as one big fraction and see what cancels. Okay. Put your equal signs. All right, take a look. So either correct me if I made a mistake or tell me you got the same thing. You got the same thing. Excellent. Yeah. So I wrote it as a one big fraction. I haven't canceled anything yet. Did you cancel anything? So it is all one big fraction. See, we can just cancel. What cancels here? X plus 4. X plus 1. Anything else? No. X plus 1 equals 0. Negative 1. And x plus 4 equals 0 is negative 4. All right, so let's rewrite it. What do we have left on top? Not 2x, be careful. X times x, x squared. And do we multiply these out like FOIL? No. All right, because, I mean, you could. It's not wrong if you multiply them out, but if you are going to do something else with this, you need it in its factored form. And we're only doing one step right now. We're going to add more to it later. Did anyone get the same answer? Perfect. What about divide? How do we divide fractions? No one likes it written this way. You can rewrite it before you start with the divide symbol in between. That's fine. So it could be the way I've written it, a fraction over a fraction. Right, or with a divide sign. Now how do we divide fractions? Right, you rewrite the first, multiply by the reciprocal of the second, and maybe you don't say reciprocal to yourself, you might say flip over the second one, or whatever words you say with it. Now, the problem is that what people do, very, very common mistake, is that they forget to flip it over. Even though I think you know you're supposed to flip it over, you get confused at what it looks like flipped over. So the x squared would have to be on top to have it flipped over. Okay, there's not much to factor here. I see a couple things I want to point out, though. So this is x squared, x, and 2x plus 1. Make sure you put that in a bracket. Does anything cancel or factor? Just the x cancels, 1x from top and bottom. So we'll have an x left. Okay, so I put it in front instead. It's not wrong not to put it in front, but it's more standard to put like an x that doesn't have a linear term in front of any brackets. Okay, so it's standard, but not wrong. You could have the x second. It doesn't matter. You could leave it here. What else are we missing? X can't be 0. And I see there's something I want to point out. People don't like this. Who in here doesn't like the look of that and feels like they should flip that around? Yeah, and so when you flip it around, you get it wrong. So my advice, first of all, is try to like it how it is. Okay, and my second advice, if you need to flip it around for your own sanity, to feel better about it, how should it look? Right, negative x plus 3. Be careful. Do you see what I'm saying? And then that, to me, I don't like, this one. But I understand you wanting the x first. Now, the other thing is, what if we wanted to factor out a minus 1 from this? We've done it already when we did factoring when a wasn't 1. X minus 3. So we could write this as minus x minus 3. So this is not to do with this question. This is off to the side. Okay. These are all equal. Right? I didn't add in a -1. What I did is just moved it around. If we multiply that negative back in, it changes both signs, which gives us this, which is the same. Okay, so these are all equal. And the reason I wanted to point this out is I just thought about this. We do see this in calculus sometimes. Ideas? Does it? There's a lot of x's and 3's, so something might cancel. What could we do? I already answered it in the note, one line above. We can factor out a minus sign here. It's right here. Now what if all of that cancels? What do we have left? -1, right? What if it had been like this? Okay, so don't just look at it, write something. You can always scratch it out if you don't do it right. Write something down. What's the answer to that? I see a lot of people thinking or trying to look like they're thinking. The minus is on the bottom. We talked about this lots of times. Does it matter? The minus can be on the bottom of a fraction, in the middle, or on top, and it's all the same. So what's the answer here? I mean, if you want, cancel them out, and you say this is, if you want to do it that way, but it is the same answer. Do you see it? Okay, one last crazy question for today. Ready for it? Crazy because it's really big and it's going to look scary. So backing up to the last question, right here. Here we had a fraction divided by a fraction, but it was a fraction divided by a fraction. One fraction on top, one fraction on bottom. We flip over the bottom one and multiply. We can't do that here because it's not a single fraction. So what do you think we do first? Right, common denominator, top, bottom, get it so that it is one fraction over one fraction. Then we can flip the bottom one over. Does that make sense? Now, we are making sure that every line we write is equal to the line before. So if you're going to do this, this is kind of a long, you have to sort of do it at the same time. The other option when you have a big long question like that, if we need to find this as a single fraction, do it separate off to the side, get the answer, and then rewrite the question with your single fraction. So a single fraction using common denominator. Let's call the top A, and then do the same thing here, single fraction, by finding a common denominator. And let's call that one B. So we'll have an A and a B, we put them back together. Does that make sense? You don't have to do that. You can write the whole thing, line after line after line, and do them both at the same time. But you would then, as soon as you put an equal sign here, you have to write everything, not just top and bottom separate. So here we're going to do A first. So we're just going to rewrite the top, forgetting about everything else in the question. And this goes back to when we did fractions earlier that were linear, it has no x squareds in it. What's the common denominator? X times x plus 1. What do you not do that some people would do by mistake? Add 1 to this one, right? You never add to find a common denominator, you multiply. So none of these can be factored further, so we just use that as the common denominator. So 1 minus x over x. We need to multiply this one by 1 plus x. And the second one, we're going to multiply just by x. Make sense? Now they have a common denominator, so write it as one big fraction. Now what do we do to this? Leave the bottom as it is. It's already factored, but we need to work out the top. So how would we do that? FOIL. And x times x? X squared? Okay. So 1 times 1. 1 times x. Minus x times 1. Minus x times x. Plus x squared. Interesting. What do we have left on top? Just 1. This was a difference of squares, isn't it? It's the same two numbers, one with a plus and one with a minus. So when you work that out, you get 1 minus x squared, the 2 with a minus sign in between. You don't really need to notice that, but to get it. So there's the top, that's A. Do the same thing with the bottom. There's nothing to factor, so do your common denominator. The first one we need to multiply by 1 minus x. And the second one by just x. Write it as one big fraction. FOIL it out. Still it's difference of squares. It's actually the same thing we had here on the top. Do you see it? Is it the same thing we had here? It is, exactly. So still 1. All right, there we go. Now this is actually a similar question. You see these on the placement test with just numbers in them. The method is the same. This is just a little bit trickier with letters, but the method is the same. Okay, so, whoops. So we want to put it back together, A over B. So A was 1 over x times x plus 1, and 1 over x times 1 minus x. Top multiplied by the reciprocal of the bottom. They're multiplied, so it's one big fraction. The x cancels. Anything else? No, even if you factor out a minus 1, it's still going to have a negative in it. It's still different than that one. That's not the same as what we were doing before. So the x does cancel. And what would our condition be? Yeah, you can put the 0 in. We canceled out the 0. I want you to, though, to look at the top, the very first question. We didn't cancel any more x's anywhere off the bottom, so this will be okay. This is right. But if you look at the original question way up top, what x values can we not plug in here in the original? So the first fraction, what can we not put in this one? 0. This one? -1. Okay, let's remember that. Okay, 0, -1. Here, 0, I already listed it. And here, +1, right? 1 minus 1, if we put a 1 in there. Now, look at the final answer. Is any of them missing in what we have here? What can x not be in our final answer? Do we have the 0? It's missing. What can x not be in this one? -1, so that one's okay. What about the 1, though? It's gone. Now, this only happens in these special ones, okay? So the other types that we saw, that this never happens. But we still need the other condition. Now, how could you avoid worrying about that? We don't need to list the -1 because it's still there in the final, okay? Now, someone over here asked twice, actually, last class, the same thing, like, can you list more? Can you list all of them right from the start? And the answer is yes. So if you had looked at those at the very start, you listed them all, even if you list the -1, it's okay. Right? It's just redundant because it's still there, but you can do it that way, okay, if you're worried about missing something. And you have to list the restrictions always in every question? No, unless I ask for them, and I'm always going to ask for them. But in calculus, you won't need to, right? So you don't need, you'll be doing something else with it, and you'll have gotten those numbers from somewhere else. So the answer is, in this class, I'm going to specifically say, give the restrictions. If you give extras that were in the original and that are still here, like the -1, that's still okay. So you can always look at the start, write the restrictions down right away. Okay? Or you can wait and as you cancel things out, keep track of them. Okay? Either way will work. Probably from the start will cause less mistakes. So that's the end of that section.